All right, let's finish up these polynomials. On number 16, what does it mean? Let's see, when we looked at exponents, we found that when you have something, and this is a binomial now, raised to the second power, with a regular exponent, right, it meant you had two of them. It means exactly the same thing when you're dealing with binomials or polynomials. When you have z minus 9 raised to the second power, it actually means you have two of them, and you'll actually have to expand it out in order to be able to do it. You can't do it right there. You have to actually write it out and do the distribution process. Start with the z. We're going to distribute it onto everything in the second parentheses. Z times z is z squared. Z times negative 9 is minus 9z. Then scoot over. Negative 9 times z is minus 9z. And negative 9 times negative 9 is positive 81. Now combine like terms if you have any and write the answer in descending order. There is only one squared term, so I'm going to write it down. I do have a couple of z terms. Negative 9z and negative 9z add up to negative 18z's. And we do have one constant, so I'll bring him down. That's it. Let's do it here. Stop the video and try this one on your own, and then come back and see how you did. All right, if you have 4 minus a, that quantity squared, it means you've got two of those. So you're going to write them down and do exactly what we did before. We're going to multiply everything in the first parentheses onto the second. We're going to do the distribution process. Start with the 4. 4 times 4 is 16. 4 times negative a is minus 4a. Then distribute the negative a. Negative a times 4 is minus 4a. And negative a times negative a is a positive a squared. Now let's write the answer in descending order and combine like terms at the same time. We've got one a squared term, and we know he's got to go first. A's are going to go next. Got two of those, negative 4a and negative 4a combined to make negative 8a. And I've got one constant. I'll bring him down last. All right, let's go on to number 18. If we're multiplying a 2-term phrase onto a 3-term, see, this is why I don't use that special F word, because the distribution process works no matter what it looks like. And this is a great example. Let's do it. We're going to multiply every piece in the first parentheses onto the second. We'll start with the x. X times x squared is x to the third. X times 2x is 2x squared. X times 4 is 4x. We finished with the x, so let's scoot over to the negative 2 now. Negative 2 times x squared is minus 2x squared. Negative 2 times 2x is minus 4x. And negative 2 times 4 is minus 8. After you get it distributed, we can combine like terms. But we're going to also write our answer in descending order, so let's start with the x to the third power. Well, there's only one of those, so that was pretty easy. Next, I noticed that there are two x squared terms, but they happen to cancel. A positive 2 and a negative 2 cancel. Next, let's do the x's. I've got a 4x and a negative 4x. Well, they cancel too. That happens sometimes. And finally, we've got a constant. So that was pretty cool. And that also is actually a special product that you'll become aware of as you take more and more math. Now look at number 19. This one is actually a 3 binomial product. And another cool thing is, like, you know how it doesn't matter what order the numbers are in when you multiply them? You can move these factors around as well. Now, I'm going to go ahead and multiply these two together first. And then I'll talk to you about what we're going to do with this guy. I'm going to hold on to him right there. I don't want to forget about him, though, so I'm going to highlight him. Let's distribute among the first two first. You have to do them two at a time. 3x times x is 3x squared. 3x times 5 is 15x. And then I'm going to scoot over and do the negative 1. Negative 1 times x is negative 1x. And negative 1 times 5 is negative 5. I'm going to go ahead and clean that up. The squared term is 1, so I'm going to bring him down first. I've got two x terms. 15x's and minus 1x is going to give me 14x's. Just a constant, negative 5. Okay, what I found, what this is those first two terms multiplied together. But I'm not done. I need to multiply those now by the x minus 4. Now, I could have left them at the other end, but I like the smaller piece at the front. And you can actually rewrite it so that the smallest one goes last and it's in the front. It makes it a little nicer to distribute. Start with the x. X times 3x squared is 3x to the third. X times 14x is 14x squared. And x times negative 5 is minus 5x. Then scoot over. We're going to distribute the negative 4. Negative 4 times 3x is minus 12x squared. Negative 4 times 14x is, negative 56x. And you can stop the video anytime you need to if you want to multiply. And negative 4 times negative 5 is plus 20. I'm going to scoot them over a little bit for us. All right, we've done all three terms now have been distributed in. So I'm going to combine like terms and write the answer in descending order. So start with the largest exponent term. I've only got one. That's always nice. I've got a couple of squared terms. 14x squared and negative 12x squared are going to add up to 2x squared. I've got an x here and an x term here. When I add negative 5x's and negative 56x's, I get negative 61x. And finally, I've got that constant, so I'm going to go ahead and bring him down. There you go. All right, the last thing we're going to look at is dividing by a monomial, which I think is super cool. It looks like, it is a division problem, but you're dividing by a single term, a single monomial. If you're doing this, the easiest way to do it is to rewrite it. Everything on the top, I'm going to write down. But instead of making one ugly fraction, put the denominator under each one separately. It is always easier to reduce three little fractions than a complex one. So reduce. 2 over 4 reduces to 1/2. I reduce my x's. 3x's on the top, 1x on the bottom is going to give me x squared on the top. There's my first term. Negative 8 and 4. That's going to reduce to a negative 2. And I've got x's, and again, I'm not sure that it's not going to have a denominator, so I'm going to keep him there. X squared on the top, 1x on the bottom. 1x will cancel. I'm still left with 1 on the top. Next, 12 over 4 reduces to 3 over 1, and the x's completely cancel. Let's see what we have left. I could leave it that way, but I don't really like the ones in the denominator, so I'm actually left with x squared over 2, and I could put the 1 there if I want to, minus 2x plus 3. Let's try another one. Again, rewrite the numerator first. And then put that denominator under each one by itself. Now you can reduce. The first one's kind of cool because the 6's completely cancel, don't they? And I end up with x to the 4th over x squared. 2x is canceled, but I'm still left with 2 on the top. Then you go on to the next term. A negative 2 over 6 reduces to a negative 1/3. I've got 3 x's on the top, 2 x's on the bottom, which is going to leave 1 on the top. 12 over 6 reduces to 2. and the x squares cancel. I don't like, well, actually that is fine that way, or you could write it prettier. I do want to show you one thing. Even on this first, well, let's do it here first. That is okay, and that is 100% correct, going to get you all the points. But here's a prettier way to write it. If it's on the top, you can actually pull the number off of the x and put the x right next to it. That's okay too. So, or this second answer. And that one's just making it pretty. Math nerds like that, and I'm one of those. That's one reason I like to keep the 1 there, because it reminds me that I also could have written that as 1/2 with the x squared next to it minus 2x plus 3. But again, you're welcome to stop at the circled answer. I'll see you in the next notes.